rather than a normal mail bag where we open all these up and pretty much do nothing with them, I'm going to open these up one at a time. So they'll go back into the box and then we'll open them up and we'll do something with them straight away. The Dirty Dozen, part 2, and we'll try this one, which is a module of some description. Says RPi 2040. So some sort of Raspberry Pi module of some description. Okay. What can we do with a Raspberry Pi? Well, I haven't done an awful lot with Raspberry Pis. This looks like some sort of Pico clone, actually. No Wi-Fi or anything on there. Interesting. I'll get a little bit closer and let's check it out. So we have our RPi 2040 front and center, crystal, a few other caps and whatnots around it. We have, it looks like USB-C coming in. That's nice. Voltage regulators and the like. This one is, it says WinBond on it, so I'm assuming that that's flash, probably 4 megabytes of flash. And we've seen these chips before because I've used them to upgrade the ESP01 from 1 megabyte of flash to 4 megabytes of flash. So that is the same chip. We have a boot button. We have a reset button. We have a user button. Interesting. So maybe that's something that we can program so that when we press that, something happens. That's nice. We've got what looks like an RGB. In fact, in the middle of it there looks like a chip. So I want to say that's probably an addressable RGB, which is pretty cool as well. And then on the back, nothing. So some headers to solder up. And I guess we could talk to it via the via these pins here, but I'd probably like to talk to it. That's an interesting effect. Probably like to talk to it via the USB-C on the end. What we could probably do with it is, I haven't done an awful lot of Python work, so let's do some Python work, maybe to incorporate this user button. And also we could maybe do something like, there is some rumors that the ADC on here is a bit flaky. I think it's called something like non-linearity, which basically means that the ADC has some glitches along the way. I'll see if I can find some information about that and put it up here. But it is, I think it's supposed to be pretty good ADC apart from that in terms of its, I think it's like 12 bit. So that's pretty good. So maybe what we could do is we could, we could have a light dependent resistor and we could have it feeding into one of these, and then we could cover it up, and then something happens with this addressable LED here. Maybe the amount that we cover it up. That sounds good. So we'll press the button to start. We'll have a light dependent resistor, which is maybe showing brightness on here, and then as we cover it up, maybe the brightness goes down on the LED. That sounds like a plan. Let's get the LDR out and solder it up first, and we'll solder these pins on as well. Well, this is going to be a bit noisy and boring. The noisy I can fix, but the boring is a little harder. So I might go into a montage with a bit of music in the background while we get this soldered up, and we'll put the pins on the Raspberry Pi module. I have spent many hours in the past looking for bugs in code which involve light-dependent resistors in this sort of voltage divider format. And only to find out that there was some problem with my the way that I'd wired it up, or the LDR was faulty. That's very frustrating. So now, having learnt from that, what I actually do is to test these things to start with. We've got 5 volts coming in across the LDR. We didn't see this bridge put in the montage, but there's a little bridge here and that creates a divider, and that's where I'll pull the signal from, and then off to a 10K pot, which you can use to adjust the sensitivity of the whole shebang. So with 5 volts coming in, we've got, out of our voltage divider, 4.34. The whole idea then is if we cover up the light, we should be able to see that drop away. And it does. And in fact, we can reverse this so we can have the 5 volts coming in across the pot and then off via the LDR to ground, and that will go the other way. That will give you a signal which is increasing voltage with the light. Let's do that, actually. Yeah, nice. So 5 volts now coming in, goes across the pot to start with, and then there's a signal drawn off there, and then out to ground. And you can see that's quite low resistance to start with, and if I cover that one up, it should climb. And it does. I'll see if I can put my emits all the way over the top. Yeah, that's climbing up quite a bit. That's working, that's nice. The next thing to do is to put this into the circuit with the Raspberry Pi module and see if we can get some sense out of that analog to digital converter that's in there. Here's the code running on Thonny, which seems to be the preferred IDE for MicroPython, and it's running directly on the device itself. So I can just go Save As and choose the MicroPython device and write over the top of main, and that is it. Now, it's already open, so that's not going to work, but basically that's how easy it is. I've borrowed pretty heavily from the internet here. I've just got my LED, my single onboard LED, pin number 23 according to the pinout, and at a pretty low brightness. I've also got my light dependent resistor on pin number 27, and I've set the initial LED brightness that it's measuring to 0, initializing the variable. Then I've got lots of different colors as defined here, and then I've got an array of all those colors pretty much in order of what I want to show for brightness. Then there's a lot of guff associated with using the WS2812, which I won't go into. You can dive as deep as you want on that, but basically all it does is it allows you to set and display those colors. Now, when it first initializes, it goes through the array. So for color in colors, firstly fill the pixel and then show it, and then sleep for 1.5 seconds. So it'll just go through all of those colors in order, just to test them, I guess. And then the loop. So while true, the light LED variable is set with whatever the LDR is reading through the ADC, through the analog to digital converter. Then it's just got to print it, which will come up down here in the shell to tell me what the light level is. And then finally, just some if statements here. So if it's greater than 2500, then go white, otherwise go cyan, yellow, and so forth down to black. And then show that color, and then 0.2 seconds later, 200 milliseconds later, do the whole shebang again. So it should be sampling 5 times a second, which is probably enough. So when I run it, it will come up here. So it's just going through its colors at the moment. And when it's cycled through the colors, it'll start measuring, and there it goes. So at the moment it's around 2500 in here. So it's getting a bit darker. And what I can do is I can just move my hand over it, and you can see that it changes. Probably want to see that effect in real life to see what happens. I'll just wind that back down. But that's the simple code. Never used MicroPython before, but yeah, pretty straightforward. As long as your indentation is correct for Python and you've had a bit of a play with it before, you should be fine. Let's have a look at it in real life. Just powering this through a power bank, and there's our colors: white, cyan, yellow, green, purple, red, blue, and black in order of the amount of light. So it's white now and sampling every 0.2 of a second. And so if I bring this over the top, we should see it go down through that again. It's pretty sensitive. Maybe I can affect that as well. Whoop. So there was white, cyan and yellow, green, purple, red, blue and black. Nice. And you can adjust the sensitivity, of course, either in the software or with that pot. So that's nice. I'm pretty impressed with this little Raspberry Pi. Particularly, I didn't end up using the user button, but particularly with all the bits and pieces, a user button is useful. The onboard LEDs, there's a couple of them which are useful. And of course, the WS2812, the addressable LED, is pretty fine as well. When powered from the USB, you've got 5 volts out if you need it, and here's ground here, and I've just connected up the rails together, and the rest of it's pretty much as we saw on the breadboard before with just the LDR configuration. That is the circuit working for this week. The Dirty Dozen Part 2 is done. See you next time.